So welcome to chapter 3. So in this chapter is the major classes of chemical reactions. So in this lecture we'll talk about solution concentration and role of water as a solvent, and we'll also try to understand how to write equations for aqueous ionic solutions reactions, and finally we'll talk about precipitation reactions. So let's start with water. Water is a polar molecule. So which means that it has an uneven electron distribution within the structure because it also has a bent molecular structure. So water is also readily dissolved. It dissolves a variety of substances because water itself interacts strongly with its solutes and often plays an active role in aqueous reactions. So water is also called a universal solvent. So water is also called a universal solvent. So this is a distribution. This is a diagram that shows the electron distribution difference between hydrogen and water. So when you look at hydrogen, notice the blue region here represents the electron, the positive charge, and the red region here represents the negative charge. So notice the distribution is even, where the electrons are more concentrated at the center and less concentrated at the edges as well. But notice the electron distribution in water. There is a lot of concentration of molecules on the oxygen and more positive charge concentration on the hydrogens. Because of this, it has an asymmetrical electron charge distribution. Because it has an asymmetrical distribution, so it can create what we call a polarity. Polarity is where it can create a partially negative charge on the top and partial positive charge on the bottom. So combining both the positive charges, you get the resultant positive charge in the middle of the molecule at between the two hydrogens as the net positive and net negative on the oxygen. So this is why water molecule is a polar molecule. So what happens, what do you do with this polarity is that the polarity causes it to dissolve any ions. So when you dissolve an ionic compound in water, for all the positive charges, notice that this is the partially negative charge and this is the partial positive charge. So all the partial negative charges will surround the positively charged molecule or the positive ion, and all the positive charges will surround the negatively charged ion, causing it to form a shell, and this shell is called as the hydration shell, and it facilitates movement in water. So because water itself surrounds themselves, so it dissolves readily because the molecules are trying to split themselves apart and form positive and negative charges, and once they form positive and negative charges, it makes their movement easy, where it facilitates their movement from one position to the other position. So this is the idea behind the topic of water. Next, one another property that is specific for water is the electrical conductivity for ionic solutions. So when you take ionic solutions where you have distilled water, in distilled water there is no current because in distilled water it does not dissolve. Distilled water by itself does not have any current. But when you take, just say for example, salt, the positive and negative ions are fixed in a solid, so they do not conduct any current. But when you melt this ionic solution, it will conduct, but it is really good when you have a solution, and when you have a solution of the ionic compound mixed with water. So this creates easy movement of the positive and negative charges inside the medium due to the formation of the hydration shells. And the positive and negative charges do not collide each other because all the molecules are running over one another. So this is how the hydration shells are generally created inside the water ionic solutions. So let's take an example. So the beaker here contains an aqueous solution of a strong electrolyte, potassium sulfate. So which beaker best represents the compound in the solution? So they are asking you that H2O molecules are not shown. And B, if each particle represents 0.10 mole, what is the total number of particles in the solution? So if you look at the molecule, if you look at the problem here, so they're asking you for potassium sulfate. So what is potassium sulfate? So potassium sulfate is the first thing that we want to. So what is potassium sulfate? We know that potassium is K plus, sulfate is SO4 2 minus. So potassium sulfate, so exchange the charges, so you get K2 SO4. So when you mix it in water, K2 SO4 mixed in water dissolves into 2K plus SO4 2 minus. So for 1 mole of potassium sulfate, there is 2 moles of potassium ions and 1 mole of sulfate ions. So remember the idea here for each given mole salt. So this is the original solid, and when it's in the aqueous solute form, it becomes the ions. Right. So for every one particle, you have 2 particles here. Now let's look at the diagram and look at where if it matches any one of them. So for each one positive, there is 2. So for one negative charge, there is 2 positive charges. So which structure represents for each negative? You have 2 positives. So you have 2 minus for one positive. So let me write it this way. There is 2 minus here, and there is 1 plus. So for every 2 minus, there is 2 1 plus, 2 of them. So which one represents that correctly in all of the diagrams here? So in all of them, beaker A and beaker B show 1 plus and 2 minus particles that are not dissociated, meaning that they are not separated. So this is not the solution. Again here there is partial dissociation. This is also not true because all of them have to be dissociated. So the idea here is that for every 1 molecule of SO4 2 minus, there should be 2 molecules of 1 plus. So for every 1 molecule of 2 minus, there should be 2 molecules of 1 plus. So let's look at option C here. There are 3 2 minus. For 3 2 minus, there are 6 plus. So there are 3 2 minus here and 6 2 plus 1 plus. So which means that this is the right answer. So option C is the right answer. So this is how you can check your problem. So let me give you some more examples so that you can solve some on your own. Alright, so pause the video right here and try to solve this problem. So let's try another problem. So here we have what amount or a mole of each ion is present in each solution. So let's start with the first one, A. So they are asking 5 moles of ammonium sulfate. So the first one is 5 moles of ammonium sulfate. So what is ammonium sulfate? Ammonium is NH4 plus, sulfate is SO4 2 minus. So which means that the original compound is NH4 taken twice SO4. Right, so when you split it, notice that there are 2 of them here. So you get 2 NH4 plus SO4 2 minus. So for 1 mole of NH4 plus NH4 ammonium sulfate, you get 2 moles of ammonium ions and 1 mole of sulfate ions. Now, how many of them are there in the original problem? You have 5 moles. So if this is 5 moles, what should be each of these values? Now take the ratio separately. For 1 mole of ammonium sulfate, you get the 2 moles of ammonium plus ions. So if this is 5 mole, how much should this be? So take it as X and cross multiply. So when you cross multiply, X becomes 2 times 5, that becomes 10 mole. Right, so this value is 10 mole. So this is 1:2 ratio, so that 5 becomes 10, right, times 2, right, times 2. Next, from 1 to 1 here, so 1:1 ratio, so 5 becomes here 5 moles. So we have the value now. Next, let's try B. We have 78.5 grams of cesium bromide. So always convert mass into mole. So you have cesium bromide. So cesium bromide is CsBr. So we are finding the mass. So the number of moles, sorry. So that's mass of cesium bromide over the number of moles of cesium bromide. So mass of cesium bromide is given, which is 78.5 grams over the molar mass. So when you want to calculate the molar mass of cesium bromide, the value becomes, so cesium bromide, when you take it from the periodic table, you should get a value of 212.8 gram per mole. So it becomes 212.8 gram per mole. So that becomes 0.369 mole of cesium bromide. Now we know that cesium bromide splits into Cs plus Br minus. So for each mole, the ions are also 1 mole each. So we can say that if cesium bromide is 0.369 mole, then automatically cesium is also 0.369 mole. Bromine is also 0.369 mole. So this is how we can split the values. So let's try the last one. So the last one is 7.42 times 10 to the power 22 formula units of copper to nitrate. Copper to nitrate. Now, how do you convert this here? So again, it's in the number of molecules. We want the number of moles. So we know that the number of formula units is equal to the number of moles times the Avogadro number. So if you want to find the number of moles now, push this down to the other side. So N becomes, so the number of formula units over the Avogadro number. So the number of formula units is 7.42 times 10 to the power 22 over 6.022 times 10 to the power 23. So when you calculate the value, you should get a value of 0.123 mole of copper 2 nitrate. Copper 2 nitrate is CuNO3 taken twice. Now, when you know that CuNO3 taken twice, when it becomes an aqueous solution, it becomes Cu2 plus 2NO3 minus. So which means for 1 mole of this, you get 1 mole of copper and 2 moles of nitrate. So if this is 0.123 mole, so it's 1:1 ratio, so this will also be 0.123 mole. But this is 1:2, so which means twice the value. So 0.123 times 2. So that becomes 0.246 mole of nitrate. 0.123 mole of copper and 0.246 mole of nitrate. So this is how you can find the values. So let me give you some practice problems so that you can try some on your own. So pause the video right here and try to solve these problems. So next let's talk about concentration of solutions and molarity. So solutions are generally categorized based on their concentration. So concentration here refers to the amount of solute that is present in a given solvent. So what is a solute? So most reactions that generally occur are always occurring in a solution. So what is a solution? A solution is either two or more solutes plus a solvent. So solute can be in any phase. It can be a gas, it can be water, it can be air. Sorry, it can be solid, it can be a liquid, or it can be a gas. Solvent can also be any one of these three. So, but most solvents are generally liquids, and the solute is what changes here. So, the concentration of a solution is basically the amount of solute that is present in the amount of solution. So, one of those measures that we use to represent it is called molarity. So, molarity is the common one that is used to express concentration. So, it is defined as the number of moles of solute over the liters of solution. So, the moles of solute by liters of solution. So, let's try a problem so that it becomes easier to understand molarity. So, here it is given that what is the molarity of an aqueous solution that contains 0.715 mole of glycine in 495 ml of water. So, how do you classify this? So, the number of moles, so molarity is the number of moles by volume. So, remember that volume here should always be in liters. Right, should always be in liters. So, if it is an ml, so 1 ml is 1 over 1000 liter. Right. So, 1 cc is also 1 over 1000 liters. So, the number of moles is given in the problem is 0.715 mole, and the volume is given as 495 ml. So, to convert it into liters, divided by 1000. So, 495 over 1000 liters. So, that becomes 0.495 liters. Now, how do you find the answer for this one? So, molarity becomes the number of moles is 0.715 over the volume is 0.495. So 0.715 by 0.495, that gives you 1.44 molar glycine. So what you represent is actually the solute concentration in a solution. Right, so this is how you represent the problem. So let me give you some practice problems so that you can do these on your own. So try these two problems. So in this, the first thing is given in mass. So convert mass into moles. So by using the formula N equal to mass by molar mass. So the potassium iodide is the solution. Next, in the same way in the other one as well, milligrams. So convert first into grams and then convert it into mole. Right. So sodium nitrate is NaNO3. So NaNO3 is sodium nitrate, and they have converted it into ml. So ml converted into liters. Alright, so pause the video right here and try to solve this problem. So now let's try to do a problem where they have given us how many grams of solute. They are asking us how many grams of solute are in 1.75 liter of 0.460 m sodium monohydrogen sulfate solution. So here we are converting from molarity into, so we have to find the number of grams of solute. So before we find the number of grams of solute, we have to find the number of moles of solute. Right, so if you find the number of moles of solute, it becomes easier to find the number of grams of solute. Now, so you have the volume, which is 1.75 liters, and you have the molarity, which is 0.460 m, and it is sodium monohydrogen phosphate. So sodium monohydrogen phosphate is Na2HPO4. Right, so Na2HPO4. So we know that molarity is number of moles by volume. So we want to find the number of moles N. So N becomes molarity into volume. So molarity is 0.460. Notice that volume is in liters already. We don't need to convert it. So that becomes 1.75. So 0.460 into 1.75, that gives you a value of 0.805 mole of Na2HPO4. So we have found the molarity now. The next one we want to find is the mass of the solute. How will you find the mass of solute? So mass M is, so we know that number of moles is mass by molar mass. But here we want to find mass. Mass is number of moles into the molar mass. So the number of moles is 0.805 into the molar mass. So molar mass, here we are finding it for Na2HPO4. So what is the value that we get for that? So that value is, I'm going to write it directly. So the value is 141.96 gram per mole. So 141.96 gram per mole. So mole gone. When you multiply, you get 114 grams of Na2HPO4. So this is the mass of solute that is present in that solution. Right? So I hope you understand this. Let me give you some examples for practice so that you can try it on your own. So pause the video right here and try to solve these problems. So let's try another problem. Here they're asking you what amount of mole of each ion is present in 35 ml of 0.84 m zinc chloride. So when you write zinc chloride, so zinc chloride is ZnCl2. Now, so the volume here is 35 ml. Always convert it into liters. So 35 by 1000. So that becomes 0.035 liter. So this is the volume. Next, the molarity is 0.84 m. So that's the molarity. Now we have to find the number of moles of each of these individual ions. We know that ZnCl2, it splits into Zn2 plus 2 Cl minus. So for 1 mole of ZnCl2 we have 2 moles of, so we have 1 mole of zinc and 2 moles of chlorine. So first let us find the number of moles of zinc chloride itself. We don't know how much this is exactly. So number of moles is, so we know the formula from molarity is number of moles by volume. So number of moles becomes molarity times volume. So molarity is 0.84 m times volume is 0.035. So when you calculate the value, you get the number of moles. So that is 0.029 mole of ZnCl2. So this value now is 0.029 mole. So this is a 1:1 ratio, which means that zinc ion is 0.029 mole and Cl minus ion is 1:2 ratio, which means that this is 0.029 times 2. So that becomes 0.058 mole. So you have 0.029 mole of Zn2 plus ions and 0.058 mole of Cl minus ions. So Cl minus ions. So this is how you can differentiate and find your answer. So let me give you some practice so that you can try it on your own. So pause the video right here and try to solve these problems. So next let's discuss what is the difference between a concentrated and a dilute solution. So in a concentrated solution there are more solute particles in relative to a dilute solution. So a dilute solution there is more solvent than solute. So the comparison here is that the more the solvent, the lesser the amount of solute particles. It's not that we are reducing the solute particles, we are increasing the amount of solvent that is there inside the process. Now let's take an example. So it's saying that isotonic saline is a 0.15 m aqueous solution of NaCl. How would you prepare 0.80 liter of isotonic saline from 6 molar solution? So the common method of preparation is to by adding a certain amount of solvent. Now this brings up the question, so they are asking you how would you prepare it. So preparing it needs the amount of solvent. So how much is the amount of solvent that you prepare? Remember that the idea here is that the number of moles of the solute is the same, is constant. So which means that the number of moles in concentrated solution is equal to the number of moles in dilute solution. So we know that molarity is number of moles by volume. So the number of moles is molarity times volume. So molarity of concentrated solution into volume of the concentrated solution is equal to the molarity of dilute solution times volume of the dilute solution. So remember this formula. So this is the formula for changing dilute into concentrated or concentrated into dilute. So here we are finding the volume of dilute solution because the concentrated solution's molar mass is given. So and they are asking you, they have given a total of 0.15 m aqueous solution of NaCl, and you have how would you prepare 0.80 liter of isotonic saline from 6 m stock solution. So the stock solution is the one that we are looking at. Now the concentrated solution is, they are asking you for 0.80 liter of isotonic saline of 0.15 m NaCl. So which means that the dilute molarity is 0.15 m times the volume that they are asking us to prepare is 0.80 liter is equal to the concentrated is 6 m. So 6 m, and there we have to find the volume of the concentrated solution, the volume that we have to add to that. So what is the volume then? Volume of the concentrated one becomes 0.15 m times 0.80 L over 6 m. So how would you find the value now? So calculate the value. That should give you a value of 0. So the volume of concentrated solution should give you a value of 0.020 liter. So this is the volume of the solution that we have to add to 6 m solution to make 0.15 m 0.80 liter solution. So this is how you would prepare it. Let me give you some problems for you to practice. Right, so pause the video right here and try to solve these problems. So notice that it's given as meter cube. So 1 meter cube is 1000 liters. So remember this difference here, this conversion factor. So pause the video and try to solve this problem.